Next topic is latches and flip-flops. Okay, actually they are interconnected. The way they are interconnected we will explain later. But for the time being, we will go for flip-flops. Okay, actually, flip-flops are the basic building blocks of sequential circuits. Okay, any sequential circuit designed will definitely have this particular flip-flop. Okay, and as they are the basic building blocks, actually what is a flip-flop means it is a group of logic gates. We have studied the concept of logic gates and all. So actually flip-flop is a group of logic gates, and let's go to points directly. The most important memory element is the flip-flop, which is made up of an assembly of logic gates. There are several different logic arrangements, different gate arrangements that are used to construct the flip-flops in a variety of ways. Next point is each kind of flip-flop has special features. In the coming sessions we will see a kind of a variety of flip-flops. They are SR flip-flop, JK flip-flop, T flip-flop, which stands for toggle flip-flop. Okay, actually SR means set reset. JK, as is in the alphabetical order, the J is followed by K. It just got that name. Okay, JK flip flop, and the specialty will be explained later. And we have T flip flop, which stands for toggle. Okay, toggle means a kind of inversion type, and also that I will be explained later. And also D flip flop, which stands for data flip flop. Okay, so it's each kind of flip-flop has special features or characteristics necessary for particular applications. Flip-flops are the basic building blocks of most sequential circuits. A flip-flop, also formally known as bistable multivibrator. Bistable, the word bi stands for two. Okay, bistable multivibrator means it can have two states. Okay, in the next section we will be drawing the picture or how a flip-flop can be represented. In such case, we will have two cases. We will have an output, we can have a set of inputs, and the output will be represented as Q and Q bar. Okay, that is, one will be the actual output, and other will be the inverted output. These output can also be referred to as states. So in as flip-flop is a bistable multivibrator, it will remain in one of the, it will have two outputs. One is the actual output, which is Q, and one is the inverted output, Q bar. Okay, and it can remain in either of the states indefinitely. That's a specialty. Okay, it has two stable states, that is a bistable multivibrator. It can remain in either of the states indefinitely. In state can be changed by applying the proper triggering signals. Those proper triggering signals means the clock signals that we provide. Okay, and it is also called binary or one bit memory. A flip-flop actually stores one bit of information, so it's called a binary, or yeah, it's called a binary means either it can store a value, or it can it can store either of the two values, 1 or 0, and also at the same time it can store only one case. Okay, and the actual output will be 1, and also the inverted output can also be stored. Clear? This is the continuation part. Okay, this is the figure or the general flip-flop symbol. Okay, a flip-flop can have more than one inputs, and the output will be Q and Q bar, but actually the normal output will be Q, and Q bar, that is the inverted output, will also be stored. Okay, so if anyone asks you what is the state, what do you mean by the state of a particular flip-flop, it means that what is the value of Q, that is the state. Okay, and Q bar will be the inverted state. Okay, I also told in the earlier I told that it's also called a binary or a one bit device, right? A one bit device means it can store, actually the output will be just one. Okay, or it can store, the capacity will be forget about the output. Okay, this capacity to store will be just one binary input will be stored. But when we come, the thing is that when we consider the states, it has two stable states, so it can be called it can also be called a binary device. Okay, so here is the normal output and inverter output. Here we have two outputs labeled Q and Q bar. The Q output is the normal output and Q bar is the inverter output. The output as well as its complement are available for each flip-flop. The state of the flip-flop always refers to, this is important, okay? The state of the flip-flop always refers to the state of the normal output Q. The inverter output Q bar is in the opposite state. Okay? Next one, a flip-flop is said to be in high state. This is something which you need to remember in the semester particular, okay? In particular, the flip-flop is said to be in high state or logic 1 state or set state. Okay, high state, logic 1 state or set state when Q is equal to 1. Okay, that is, this value is equal to 1. And in low state or logic 0 state or reset state, also we have a clear state. Okay, we can say that it's in low state, logic 0 state, reset state or clear state. Okay, clear state when Q is equal to 0. When the value of Q is equal to 0, we say that it's in the low state. Okay, and as you already know, if the value of 1 is the normal output, normal output Q is 1, obviously Q bar will be 0. If the value of Q is 0, obviously Q bar will be 1. Okay, so understand this case also. It should be in high state or low, when the flip flop is said to be in high state, logic 1 state, set state, Q, the value of Q will be equal to 1. Okay, and it's in low state or logic 0 state or reset state or clear state when the value of Q is equal to 0. Okay, please. This is all about the memory characteristics of flip-flops. Okay, so I have written all the points. This is the flip-flops memory characteristics. In order to get all those concepts clear, I have written this one point in 3 steps. Okay, this is the first one, second one, and third one, and also how this particular device or how this particular memory unit element got its name, flip-flop. Okay, I have written properly. The input signals that command the flip-flop, okay, this is flip-flop, to change state is called excitations. Okay, actually excitation means can also be considered as a trigger. Trigger means, when a particular device is in particular state, when a trigger or excitation causes the output to change. Okay, so the input signals that command the flip-flop to change state is called excitations. These inputs are used to cause the flip-flop to switch back and forth. That's hence the name flip-flop between its possible output states, either 0 state or 1 state. Okay, can be changed. A flip-flop input has to be pulsed. Okay, a flip-flop input has to be, wait a second, it's pulsed, right? Yes, a flip-flop input has to be pulsed momentarily to cause a change in the flip-flop output. Okay, that is, if a particular flip-flop output is in 1 state and it's after getting an input pulse. Okay, so the specialty is even after the input pulse is removed. Okay, that is, I will give you the explanation when we draw the figure, but let us consider this is a flip-flop and this is in 1 state. Okay, this is the set of inputs and this is the Q output. Okay, and once we receive this particular, or we write like this. Okay, this is Q and this is 1. Okay, once based on the input or based on the pulse, we received Q value as 0 and Q as 1 and Q bar as 0. Now, it's based on a pulse. Okay, even after the pulse is removed, it can remain in that particular state. That is another specialty or memory characteristic of flip flop. Okay, a flip flop input has to be pulsed momentarily to cause a change in the flip flop output, and the output will remain in that new state. Okay, even after the input pulse has been removed. This is the flip flop's memory characteristics. And also about the application thing, an application part. Flip flop, as I told earlier, it can be used as a storage device. It can either what we call store a one value when the q value is 1, that is the flip flop is in set state, or it can hold a 0 value if it is in what we call the reset state. Okay, so also a flip flop are the fundamental components of shift registers and counters. Shift registers and counters will be taken into consideration in topics to come. Okay, shift registers and counters. For the time being, understand that this is a flip flop's memory characteristic, how this got its name, and what are the basic it can be used as a storage device. At the same time, it's also the fundamental component of shift registers and counters. Okay.